I am Neil Firth from Garlock.
I'm Dr. Darren McDonnell from SCRI-IS Technologies.
And we're here today in Dublin at SCRI-IS's world-class facilities. Darren, could you tell us a little bit about SCRI-IS and about your activities in the global pharmaceutical, biopharmaceutical market?
Yeah, I'd love to. Obviously, very welcome to Dublin. Neil, very welcome to the facility. So, look, at SCRI-IS, our main aim is to extend and increase manufacturing capacity on biotech production sites. So we're a fully independent engineering consultancy, and we will work with them to choose the best components, choose the best equipment that will enable them to have the best long-term reliability for their sites.
And as part of your work, you recently evaluated the Garlock BioPro Plus. Can you tell us a little bit about the setup for that testing and the types of work that it's mimicking in real life?
Yeah, for sure. So really what we wanted to do was we wanted to ensure that the PTFE seals were put under worst case, right? So the worst case that we would know from our client's perspective, particularly for PTFE seals, will be ensuring reliability during high temperature cycling. So that would emulate a steam in place or SIP conditions. So we subjected them to higher than average temperatures, and then we would have done a cold shock, and we would have done 1,000 cycles. Each cycle is 1 hour, so 1,000 hours of those thermal shocks. And then we were continuously monitoring their ability to withhold seal. So we would have done pressure hold testing at 3 bar, 45 psi. And then what we were also doing was checking things like the level of intrusion into the internal pipe bore and the level of adhesion or sort of stickiness onto the ferrules as well.
And what were the significant results from that evaluation?
Yeah, look, delighted to say that all of the components passed with flying colours. Yeah, look, zero leakage, zero adhesion. The intrusion was well below the requirements from the standards, so we would have tested all the components against the relevant ISO, ASME standards, etc. And yeah, look, we're delighted to say that they all passed with flying colours.
Very good.
Yeah.
And how does the test results translate to the real life benefits that the end users will see?
Yeah, look, great question. I mean, again, we developed it specifically with the requirements of our end users in mind, which are the manufacturing sites. So really what this means is the sites can do an awful lot less unwanted maintenance. So one of the main drivers of downtime in the industry is changing out seals. So gaskets, your O-rings, valve diaphragms, etc. Given the volume, it takes a significant amount of time to obviously do those. A lot of sites are incredibly conservative. They will do them very frequently, far too frequently. But with this independent data, what that does is that enables us to inform our clients that there are components out there, that there are material sets out there that can dramatically increase the time between those maintenance frequencies. And again, ultimately what that translates to is increased manufacturing capacity, increased manufacturing efficiencies.
Fantastic, all very positive results.
100%.
Super.
Yeah.
Thank you, Darren.
You're very welcome.
Thank you, Mission.
Pleasure. Thanks.